Camila is an associate professor at the University of Sao Paulo in Brazil, and she's a professor in the transportation engineering program in this university. She's involved in many different topics of our actually research, common research related to transportation infrastructures and special focus to sustainability and materials. So Camila will talk about the Brazilian effort towards sustainable road pavements. Please welcome Camila. Thank you.
Can you hear me okay? Okay. So thank you, Davide, Clara, for the invitation. It's a pleasure, an honor to be here today and to be in Palermo for the first time. It's an amazing city. I'll try to bring here today a little bit of discussion on what is going on in Brazil. We are out of Europe, North America. We have some specific situations. And the first one, well, we have a large country, a lot of people, but not distributed homogeneously along the country. So most of the people, most of the roads are located by the coast. And we also have a very different weather along the country. And it makes a huge difference in terms of pavement design, material selection. Most of the research I'm going to show here today, they are under development and mostly in São Paulo. That's where the university I am working right now. So I think this is an important point, as the focus of the roads, the main focus should be the society in general. And another number that it's not showing in here, it's the percentage of the paved roads in Brazil. We have only around 12% of our roads paved. It's a very low number. And this number, it's around this for many decades. So the investment of the public sector is mostly on maintenance. Although we also have a lot of roads with bad quality. So we have a lot of work to do, what is good. I'll try to focus the presentation in three main topics. The first one is asphalt recycling. I think is a very hot topic everywhere. We are much behind most of the European countries. I can assure that in terms of the amount of REP that we can put on our mixes. With respect to the cold mixes, we are doing a little better, but we still have a lot to do. Then I'll move for the renewable sources. There are some interesting numbers from Brazil that I want to show you, and use of other industry residues. I'm not going to say waste anymore. I've learned from Professor Molinar. Residues is fine, or byproduct, co-product, we might think about it, but no waste. And some final remarks. So with respect to recycling, I'll just pass very fast. You all know the advantages of recycling. There are many types of recycling for the wearing cores, for the base cores, with different stabilizing materials. And one important point, we don't have information in Brazil on how much REP we produce yearly. We have no idea. There is no data. And what happens in the end is the milling process happens, they just put along the road in some place, some small city, stop a truck, get the REP, normally already contaminated. So the whole process makes much more complicated to use this REP, especially for a new wearing course. So this is something that we have to realize and make it better. You're going to show some pictures along the slides. Those are the graduate students that, in fact, are the ones who does the job. So Ana Flávia, it's putting together some information and get information from the road agencies along the country, from the toll roads, from municipalities, and try to have at least a rough number of what is going on in specific regions of Brazil. We have another important topic that we have to think about it. I know there was and there is still some research in France on multiple recycling. So we are recycling now, and in 10, 15, 20 years, we have to recycle again. So there are a few research questions. First, which recycling agent should we use? The reps are not the same. The recycling agents are also not the same. How many times can we do this? Is there any maximum amount of rep that it's going to allow us to repeat this process many times? So this research effort is going on right now. I think for us, it's still far from implementation, because right now we are still doing the recycling for the first time. I mean, for the wearing course. For the base course, we have for more time, but for the wearing course, we are on the first cycle. And what happens in Brazil in terms of implementation is that normally the road authorities, the toll roads, they put low amount of rep, 15, because of the asphalt plants. Our asphalt plants are not really prepared to put more than that. And they just want to remove or to reduce the amount of new binder. So no recycling agent, no extra investigation on what type of neat asphalt binder or new asphalt binder we need. This is a point that we should also look. The previous speakers also mentioned about the life cycle assessment. This topic is also new for us. And one important point is we don't have primary data in Brazil. So we normally rely on data from Europe or from US. The energy matrix, if we compare, we just had a study between Switzerland and Brazil. The electric matrix between both countries is completely different. Most of our energy comes from water in Brazil, say 70%, 60%. And it's not the same in Switzerland, for example. China is different, US is different. So how can we rely on data that were not really collected to our scenario? So the idea of this study is to start going to the plants and start getting information from our specific case. There is a huge effort between university, road authority, the Federal Road Authority, that now they request is mandatory for new projects that they do have to implement at least 10% of rep in the mix. So it's going to change the whole chain, the whole pavement chain. The asphalt plants, they will need to adapt to that somehow. So we have to collect this information. Some information on also about recycle the asphalt plants. The way we heat the materials is very different. This is the case, the comparison between Brazil and Switzerland. Let me see if you can. If you check the dry and heat of aggregates in Brazil, we use heavy oil. And if we compare the amount of CO2 equivalent between Brazil and Switzerland that use natural gas, we can clearly see the difference. So our industry is really not aware about that. And even the plants that can do some recycling, they do not know if the production of that recycled asphalt mixture is really sustainable. Going to the cold recycling, we do much more cold recycling than hot and warm. There is one study ongoing also that the issue that we have for cold recycling is the pavement design. The national pavement design standard in Brazil is not really prepared for cold recycling, and also not for the curing process, for the change in material along the first years of the pavement. This dissection or this pavement section is the most common when we are talking about foam recycled asphalt mixture. We have a very thin wearing course and a very thick base course. So the layer that is really responsible for the performance of this pavement, it's not the wearing course, it's the base course. So what we are doing is, okay, let's see how the material change if the temperature changes. We have a couple of equations for the wearing course, but not for the bases. And what we see here, maybe it's hard to visualize, but we have 3 blocks. The middle one is all of them from the test section, the same test section, the same pavement structure. This middle one is average, this upper one is minimum, and this lower one maximum. If we compare blue and red, we see there is some difference when we collect the deflection at 7 a.m., that is the blue one, or at 5 p.m., that is the red one. There is some difference. But the difference inside the test session, because of material variability, it's much more important in this case than the temperature. So looking for the industry, looking for the implementation, we still have some steps back to organize, to try to make it better, to construct it better. Regarding the materials from renewable sources, we had this year the first workshop on biomaterials for pavements. This is a very hot topic. And I think when we are talking about biomaterials, we have to understand what about your country or what about your region? Brazil is known as an agriculture country. And I have here a chart with the main agricultural crops and also the residues from this production, the agricultural production. What we want is not to compete with the food industry. We don't want to use rice. We don't want to use sugarcane or any other food. We want to use the residues of this industry. So we are right now working with sugarcane and rice in our research group. We are in transportation engineering, and we have also a group from the biotechnology from the same university under this development. And for the sugarcane case, Brazil is very well known for the ethanol production. So when we are talking about implementation, ethanol is already in the industrial scale. The other products that comes from the bioprocesses of sugarcane or the residues of sugarcane, it's not implemented yet. So we are still in the laboratory scale. And we have a student working on that. So she's working with sugarcane bagasse and rice husk. And some initial results, we have 3 different temperatures. This one is at 40 degrees. This is a master curve, G-start master curve. 40 degrees C, 60 degrees C, and 70 degrees C. The black one is a neat asphalt binder. So for the sugarcane bagasse, for the rice husk, we had similar behavior, but only at high temperature. It's not, the materials is still very sensible to temperature. So we cannot say it's implementable yet. We still have a lot of work to do, but it's part of our research plan. Still talking about biomaterials, we had also some discussions about emissions. We have no idea how is the emissions of these materials because we are looking for a material to replace the asphalt binder, not to modify, not to rejuvenate, it's really to replace. So we are going to put this material, the idea is to have this material in an asphalt plant or something similar to an asphalt plant, a biomaterial plant in the future. How is the emissions of this? We don't know yet. So this is also a huge research effort. We have also to focus on the durability, how these materials behave with hot weather, cold weather, rain, and what kind of emissions. Regarding the use of other industry residues, I brought two cases, plastics that was also mentioned before, and the residues from the mining industry. Let's start with the plastics. Here we have another huge difference from the scenario in Brazil and the scenario for most of the countries in Europe, for example. We do not have the culture in separate what is recyclable and what is not recyclable in our own home. What is very common. I remember when I lived in Germany 20 years ago, and it shocked me. Everything was separate more than 20 years ago. Glass, paper, plastic, in Brazil is all together. Now, it's a little bit better in some cities, in some big cities, more developed cities, but not everywhere. So we produce million tons, around 3 million tons of waste plastic yearly in Brazil. It's a lot. The best solution would be, okay, let's recycle those plastics and try to return them to the same chain that they came from. We do this very well with the aluminum, very well. But with plastics, the food industry, the cosmetic industry, the requests on the purity of this plastic is too high. So it's difficult to get the plastic back to the same chain where it came from. Why pavement? We can not only keep putting, not waste, but residues on our pavement all the time. I personally do not have a settled idea on what is the best way to do. The Ryland group is studying asphalt binder modification with those recycled plastics is one possibility, but I think this scenario requires a very much pure plastic. We cannot put a plastic that we don't know exactly the composition and keep modifying the asphalt because we're going to have a different product. So the dry process, that I'm still not sure if the dry process is the best one also, because I think the idea is not to really replace the aggregate by another material. The materials are so different, the plastic so different from the aggregate. So I think we have to rethink on the way we design the mix. It's not only replace, it's to rethink on the design process. So in our research group, we have one student working on that. We are working along with the physics department and trying to understand the irradiation technique on those plastics. How does it modify the chain of the plastic itself? How it reduces the variability of the plastic, and if it really can improve the performance of this material into the asphalt mixture. So the idea on this project is to really study different plastics, especially those that are not recyclable, are not easy to recycle, for at least. Polyethylene, polypropylene are the most common to find for pavements. We want to go further than that. We want to really study those that no one wants. And the last topic is the mining industry, that it's very strong in Brazil too. We are going to focus, I'll focus on the Cooper tailings because we have a new project on that topic. This, let's see if I can, here is the Amazon, where is the two minings that we are studying are in the middle of nowhere. Nowhere. The closest city should have like 10,000 people and it's 150 kilometers from the mine. And what is the idea? We have the importance of the industry, the mining industry for the whole country, but we also have the problem. For 1 ton of copper that is produced, we produce 130 from waste. That's not going to be waste anymore. It's going to be a byproduct or a co-product. So the idea of this project is to add value somehow on this material. And on this project, these are the pictures. Looking at these small pictures, we cannot really see or at least understand how big it is. It's huge. And here are the production over the lifetime of both mines. For Sossego, we have almost 300 megatons of this residue from 2004, when the mine started, until 2027. They are almost closing this one. In Salobo, almost 1,500 megatons. It's a lot of material. The pavement industry will not solve the problem, so the project has different fields, different expertise, trying to add value in different chains for those pulper tailings. In our group, for pavement, we decided to focus on unbound layers. And why that? We don't have any asphalt plant close to this mine. So it doesn't make sense to keep transporting tons and tons of copper tailing from the mine to an asphalt plant that is far away from the region. So our idea is to focus the project with respect to the pavement on having better pavements for the small cities around the mine. So that's the focus of this project. And for the final remarks, we know that CO2 emissions is already a cost in many industries, And carbon taxes is highly probable in the future. Also, low carbon solutions are opportunities. We might create new jobs, we might create new materials, we might create new industries to develop and implement those solutions. But we cannot do it, the university cannot do it by itself, the road authorities cannot do it by itself. There is a huge chain that I've called here road construction ecosystem. We all have to be together, more and less at the same page. I'll not say the same page because the goals are normally a little different. But our main focus should be the customers. The society should be the focus. So we need material or pavements that last longer, with materials that pollute less, using as much as we can local materials so we don't have the transport costs, the transport emissions along the process. And with that, I finish my presentation. I thank you again, the organization, for the invitation, and I'll be happy to answer any questions if you have. Thank you.
Thank you very much, Camila, for your presentation. And if everyone has a question, please take a note and we will go back at the very end of the session. Thank you.